Hello. Now we are going to see power electronics. This is the diploma subject, okay, diploma syllabus based on Karnataka DTE. In that, we are going to see the subject power electronics. In the first chapter, power devices, we are going to see. Okay. First of all, why we need power electronics? What is the use of that? We need power electronics to convert and control the energy, electrical energy. Directly, sometimes we may get AC supply, but we need to give DC supply. So that time we need the converter. These power electronic devices are used as converters, rectifiers, choppers like that. In that, then um, for example, if we get 420 voltage from our main, okay, then we can't give that 420 voltage to all the appliances. For example, we need some voltage for computer, something else for washing machine like that. It varies. So based on for these conversions and control of the electrical energy, we are using power electronics. Okay, power devices. Okay, the power devices are divided into three sections, that is diodes, thyristor, transistor. Diodes are classified as general purpose diodes, high speed diodes, Schottky diodes. Okay, thyristors means thyristors are SCR, GTO, RCT, SITH, GATT, then LASCR, MCT, and TRIAC. Then transistor will get BJT, MOSFET, IGBT, SIT. Certain important things only we are going to see in this chapter. So in thyristor, we are going to see SCR, GTO. Okay. Then in transistor, we are going to see BJT, MOSFET, and IGBT. Okay. Just I'll give the expansion. What does mean by SCR? That is silicon control rectifier. GTO, gate turn off thyristor. BJT, bipolar junction transistor. MOSFET, metal oxide semiconductor field effective transistor. IGBT, insulated gate bipolar transistors. Here I said BJT means bipolar junction transistor, isn't it? That bipolar means those devices uses the two charges. They will carry both electrons and holes. I mean positive and negative and positive. Okay, that's why we are giving the name bipolar. Now this is the structure of the power diode. Power diode plus minus. Okay, this side anode. Anode A. Anode is nothing but positive. Okay, this side is cathode. Present. Cathode is minus. Okay, the current flows from anode to cathode. If the anode to cathode voltage is positive, then it is said to be forward biased. Okay, only 1 volt is sufficient enough to drive the power diode into conduction mode. Okay, that 1 volt, that is the positive voltage. I mean forward bias voltage of 1 volt is enough to drive the power diode into the conduction. Okay, when the anode to cathode voltage is negative, the diode does not conduct. It is said to be in reverse biased mode. So in reverse biased mode, it does not conduct. Okay, this is the structure of the diode. Okay, here we are. This is the cross sectional figure of the diode. In that we are having that N plus substrate, P plus substrate, N minus drift region. Anode is connected in this point, cathode is connected in this point. Here we are having N plus substrate. Okay, the N plus substrate carries electrons. P plus substrate carries holes. Okay. So when the anode to cathode current is positive, okay, the holes from the P plus region is introduced into the N minus drift region. Okay. So electrons are introduced from N plus substrate to the N minus drift region. Why we are calling it as a drift region? Because this is some sort of depletion layer that it is not saturated. That's why the holes are introduced from P plus region and electrons are introduced from N plus region. Okay, this holes and electrons form a pair. Then when the voltage is applied, the electrons are getting kinetic energy. They are getting more kinetic energy. So what will happen? They knock off other atoms to introduce more electrons from here, from N plus substrate. Okay. So the voltage, the current of the anode increases. No, sorry, the current keeps on increases in the drift region, but the resistance of the drift region remains constant. This is known as conductivity modulation of the drift region. So on-state losses are reduced here. Okay. Then N plus substrate, I forgot to tell about the doping level. N plus substrate, the doping level of N plus region is 10 to the power 19 per centimeter cube. The doping level of N minus drift region is 10 to the power 14 per centimeter cube. The doping level of P plus region is 10 to the power 19 per centimeter cube. Okay. You understand that conductivity modulation, no? Conductivity modulation of the drift region means the current keeps on increasing in the drift region, but the resistance of the drift region remains constant, almost remains constant. So this is known as conductivity modulation. Okay, this helps to reduce the on-state losses. Then this is the IV characteristics of the diode. That IV means current and voltage characteristics of diode. Here, the graph is plotted between IAK, that is anode cathode current, and VAK, anode cathode voltage. Okay, here the first quarter of the graph it shows the forward biasing. The third quarter of the graph shows the reverse bias mode. Okay, here the voltage is increasing, but at a certain level, on reaching certain voltage, the current starts increasing linearly. The anode cathode current increases exponentially. Okay, that's why we are denoting the curve like this. Okay, this side, this point VBD, this point is known as reverse breakdown voltage. Okay, when the reverse current is greater than reverse breakdown voltage, I mean in this point, certain small anode current will be there. But at reverse breakdown voltage, at that point, the reverse breakdown voltage is greater than the reverse voltage. Okay, if it is greater than the reverse voltage, then the anode current increases rapidly. This may cause damage to the device. Okay, why it is causing damage to the diodes? Because the on-state losses are high, power dissipation will be there. Okay, That's it. Then as I told earlier, 1 volt. Forward bias 1 volt is sufficient to trigger diode into the conduction mode. Applications of power diode, that they are used in uncontrolled rectifiers. They are used in choppers, inverters, and controlled converters. All commutating circuits of SCM use diodes. Diodes are used in half controlled converters and half bridge converters. Okay, thank you. If you like this video, please subscribe. Okay, in the next section, in the next video, we will see about the transistors. Thank you.